Okay, last week we found out how to find the volume of prisms, and the easiest formula is volume equals big B, and big B we found out is different than the lowercase b. The capital B means the area of whatever base happens to be on the prism, the area of the base. So when we had a rectangular prism, our base was here. The base shape was a rectangle. That's why it's called a rectangular prism. The reason it's called a prism, we found out, is because it has bases that are parallel to each other. And it's named by the shape of the base, okay? And the shape in this case is a rectangle, so this is a rectangular prism. Okay, and we found out that any right prism, the formula for volume is the area of the base. We have to find the area of this rectangle before we multiply it by the height of the prism. The height is here. The big B is the area of the base, okay? And we dealt a whole bunch with rectangular prisms last week. Now what we're going to do is there are different types of prisms. There are prisms with the base that is a triangle, or prisms with the base that's a trapezoid, or prisms with the base that is a parallelogram. And so that's what we're going to be dealing with today. Here's what our worksheet looks like for today. We're on page 12 of the same worksheet packet. Right here, we're talking about trapezoidal and parallelogram prisms. Page 12, that's it. That's it. So, good news, the formula is exactly the same. I'm going to try to draw these. No guarantees. No, that one. This one. Okay. That's as good as it's going to get. So you can see, hopefully it's better on your worksheet, but you can see that the base, we can call this front the base because the back, imagine the back, and I didn't do well on the back at all. The back goes, there we go. That's a little bit better. You can see that this front, this parallelogram, and the back are equal and parallel to each other. So that makes these the base. So the base is a parallelogram, okay? And it has two bases that are parallel to each other. That's what makes it a prism. Tomorrow we'll find out different shapes that are not prisms. Okay, so on this particular one, the measurements, I'm going to get this out so it's not so confusing. On number one, this is 19 inches, this is 34 inches, and this distance from here to here is 30 inches. So again, we have to locate the base because we have to find the area of the base first. So here is our base. If it's hard for you to look at this mixed up with the whole 3D figure, then a lot of times, if I'm going to be confused, I just pull out the base so I can just look at it by itself. So that means I have 34 here and 19 here. And notice that it does have this indicator that it's perpendicular or creates a 90-degree angle, okay? So if you go to your formula chart, under area, you can see the formula for the area of a parallelogram, area, and then it says parallelogram. And I think it just says the area of the base times the height, does it? Let me see what it says. Oh, the parallelogram, I'm sorry. It says little b times h. So to find the area of the base, don't get the small b confused with the large b. We're just finding a two-dimensional shape right here. And so the base is here, just a line. And the height has to be perpendicular to the base. So to find the area of the base, it's going to be 34 times 19. So the area of this base is 646 inches squared. And we know that we have to take it times the height. Now that's not the 19 again. Keep your brain engaged. Now it's the height of the prism, which connects the two parallel bases together. So right here is the height. Here's the base, and this connects the two together. So I'm going to take the 646 times 30. Wow. And so the volume, I'll do this, 646 times 30 equals 19,380. And what kind of units do I use here for volume? Cubed. And what's on the picture? Inches cubed, or cubic inches. You'll see them both ways on the test, or cubic inches. That's how they abbreviate it. Everybody okay with this?
Are you going to do number two? The number two with the hardest.
Number two is trapezoidal, and that's why shortcuts didn't work on that one, right?
I remember I already finished it, but you explained it to me, and now I'm looking at it again. I'm like, how did I get that?
It works. I'll do it. I'd gladly do it. Is everybody okay with this one? I think you guys are probably getting ahead of me. You're not. I mean, it's fine. I love that. I'm just, when I see you working, I wonder if you have questions. So everybody's okay?
Yep.
Yeah, okay. If you work ahead, hey, that works for me. Just don't miss any good stuff. All right. The number two almost looks like the same thing. But if you'll look at number two closely, you can see that the base, which we're going to look at the front and the back will be the same shape. And so this is going to be the base. But the base isn't a parallelogram, is it? It's a trapezoid. I don't even know if I can draw this. I will try. Sort of. This goes. Somewhere. Oh, yeah. Comes to there. Sort of. Anyhow, what I'm interested in is the base, which we decided is this. And there's one in the back. I'm trying to see why I didn't. Okay, not going to worry about it. All right. So the trapezoid, which is it's this picture. Now, the reason we know this is a trapezoid is because it has bases that are parallel to each other, but the other sides are not parallel or even equal. They can be, but they're not. So the two parallel sides, and again, we're just going to do the base because volume equals the area of the base times the height. Let me put some numbers on that. They have the height, which is perpendicular to the base, and they said this is 46 feet, and this one's 52 feet. And 31 feet and 42 feet. Okay, we have to find the area of the base, so go to your formula chart and find out how we find the area of a trapezoid this time. The area of a trapezoid. Remember, you can use this formula chart on your test, not the one that you've written on. They won't let you take that, but they'll give you a fresh one. So the area of a trapezoid, I do it differently than what's here. Okay, 1/2 the height times what you get when you add the two bases together. This is what's on your formula chart. So we're going to plug in to find the area of this so we can find big B. 1/2 times the height, which is 46, times the two bases are the ones that are parallel to each other. So I have 42 plus 52. Now you can put all of that in your calculator, or, well, probably put it in your calculator. 4 times 23.
That's the answer?
No,
Oh, that's
but that's what I was going to, that was my very next sentence, is when you get to this point and you find that answer, don't stop. Don't think, aha, because this is only the area of the base. We only found this, but we're trying to find the volume, which is how much this whole thing holds. So since I know the area of the base, I can put that number here. This is the area of the trapezoid times the height of the prism. And the height of the prism is what joins those two parallel ends together, which is 31. So now I'm going to have to take 2163, which is the area of the base. My screen isn't big enough to hold it all. 2163 times the height of the prism now, which is 31. So the volume of this prism equals 67,022. We're dealing in feet. And since we're finding volume, it's cubic feet or feet cubed.
the answer?
Mm-hmm. Did you get that answer?
Well, yeah, it says that on the paper, but how come I got it as 67,053 on the ticket?
Did you check this number?
Oh, I didn't do it square. That's why I didn't do it.
Okay. Any questions on finding area of the prism? The biggest thing to remember is find those bases so you know which area to find. Okay? Is it a triangle? Is it a trapezoid? Is it a parallelogram? You know, you'll have to find the area of whatever shape that base is, and then the other number is the height usually. Everybody okay? Not yet. Okay,
I think it's because I was sitting back there and I couldn't see what you're.
is it enough that we can talk?
Yeah.
Or do you want me to do some more?
I think that's fine. We'll just talk it.
Okay. the last thing I want to go over is a cylinder. A cylinder reminds me of maybe a Campbell's soup can, or I don't know if there's cans of dog food anymore. But a can, Campbell's soup, you know, soup can, or a tunnel.
Turn off this one.
Find my paper. So the cool thing is the formula chart gives you a different formula for the volume of a cylinder, but let me clarify to you that it is actually the same formula, y'all. If I'm finding the volume, I'm still going to find the area of the base times the height. So if you want to use that for the volume of a cylinder, you can. Here's what they give you on the formula chart, and I want to explain this. They say volume for a cylinder, and here's a cylinder. Okay, a cylinder, like a can. On the formula chart, I think it is pi r squared h. Is that correct? The volume of a cylinder? Let me see. I want to make sure we deal with that.
Yeah, height, radius, height.
Yep. Find cylinder, go clear over to volume, and it says pi r squared h, right? Well, guess what? The h is our same h that we use all the time. Pi r squared is how we find the area of a circle. And the circle is the base, okay? So either one of these is fine if you know how to find the area of a circle, the area of the base, and then times the height, just like we always do. So this one says that the radius is 5 inches. I'm on page 14. And 9 inches. This is number 1 on page 14. Now, anytime you have curves or something that deals with a circle, you're going to have the number pi in your formula. You always will. Okay. Now, on the test and on these worksheets, sometimes the instructions say use 3.14. That's just a limited decimal form of pi. If it tells you to use 3.14, go ahead and do it. If it doesn't say that, use your pi button, because your pi button gives a more exact answer. All right. And also, in your answers, in your multiple choice answers on the GED test, they're either going to have the answer in terms of pi, which will look like 4 pi or 16 pi or 7 pi. You'll have to know how to get that answer, but the same problem might have the multiple choice answers as decimals. And if it does, that's why we have a toggle switch on our calculator. So while I'm doing cylinders, we're going to find both of the answers to make sure that you're aware of which one. They're both equal answers, but we want to make sure that you know the decimal form and the pi form. Okay, so what we're going to do here, I just want you to know that this is the same, but let's use the one that's on the formula chart, and let's assume that they did not tell you to use 3.14 for pi. So we're going to say pi, and we'll use the pi button, times r stands for the radius of the base. The radius here, remember, radius is halfway. So if they give you the diameter, you're going to have to divide it by 2. We only want halfway. That's the radius. So it's 5 squared So I now have pi r squared times the height of the cylinder, which is 9. Now, if you want to go through and just put that all on your calculator, that's fine. If you're doing it by hand, make sure you take care of the exponents first. So we have pi times 25,000. So the answer coming up on my calculator is 225 pi. And again, if your answers, your multiple choice answers are in terms of pi, you will see this in your list. But what if it's all decimals? What are you going to do? Push the toggle switch, and it will give you the answer. Now remember to also look at the directions, because sometimes they'll say round it to the nearest tenth, round it to the nearest hundredth. So you're going to need to know how to round decimals. But let's say we're going to round this to the nearest hundredth. Hundredth is 2 places after the decimal. So we have 706.86. Both of these answers are correct answers. All right? You just have to know which one they want. Are we good? You shouldn't need to see any more cylinders. On page 14, you're going to have to draw some of your own. But I just draw a circle up here, bring down legs, make a circle at the bottom. Okay. 14, 15. Okay, let's look at page 16. And again, they're going to test you in conversion of units. Look at number 1 on page 16. And if you'll notice, it's a cylinder, and we're going to be finding the volume, and it shows us the radius. However, it shows the radius in yards and the height in feet. So we're going to have to convert. You guys remember the conversion where we set up a proportion? Okay. And we can either change yards to feet or feet to yards. But if we look here, they ask for the answer in yards. So we're going to leave the 5 yards alone and change the 21 feet to yards using the conversion proportions that we showed you in a video last week sometime. Okay. And if y'all have questions here in class, feel free to come up and let me renew you on that. Other than that, reading the directions, use 3.14 when they tell you to. Otherwise, use your pi button. And that's about it to finish up today. Tomorrow, we're going to talk about pyramids. Everybody okay? Any questions before I shut this down? Oh, good. Y'all did so well last week, too. Okay. I'm here for any questions.